Every cable car pillar begins here, with raw limestone aggregate arriving in precise volumes. Each batch is weighed and logged to maintain structural accuracy for offshore pillar casting. The raw aggregate now enters a controlled environment to begin mechanical processing. Rotary washing removes contaminants that could weaken concrete in marine conditions.
Controlled drainage ensures consistent moisture before precise grading begins.
Grading by size guarantees uniform strength in every structural concrete mix.
Oversized material is automatically redirected to maintain strict size tolerances. Secondary crushing brings rejected stone back within engineered specifications. Processed aggregate is now unified and routed toward controlled storage for mixing. Storage silos stabilize material flow and maintain readiness for precise concrete batching.
Cement powder is transferred pneumatically to prevent moisture and contamination.
Aeration keeps cement free-flowing for accurate dosing during mixing. Purified freshwater is essential for achieving predictable concrete hydration.
Chemical admixtures are stabilized to fine-tune strength and curing behavior.
Before mixing begins, every control and safe system is fully verified. Aggregates are measured to exact specifications before entering the concrete mix. Cement dosing is tightly controlled to preserve structural integrity in massive pillars. Water is added in measured volumes to activate the cement hydration process. Admixtures are introduced in microdoses to fine-tune performance and durability. The mixing cycle begins slowly to ensure uniform distribution of every component. Real-time torque monitoring ensures the concrete reaches optimal consistency. Thermal regulation prevents premature curing in high-volume concrete mixing. Automated sampling verifies uniformity without stopping the mixing process. Slump analysis confirms the concrete's workability for massive structural casting. The concrete mix reaches full uniformity, ready for structural forming. Before transfer, the discharge system is precisely aligned to prevent segregation. The finished concrete is released in a controlled flow for immediate forming.
Stabilized transfer preserves uniformity before the concrete reaches the molds.
Steel reinforcement cages provide the internal strength for massive cable car pillars.
Laser verification ensures each reinforcement cage meets exact structural tolerances. Clean molds and release agents allow precise shaping and safe demolding later. Reinforcement cages are positioned with millimeter accuracy inside the mold. Centering systems ensure uniform concrete cover around the steel core. Sealed molds are critical for maintaining pressure during concrete filling.
Pressure testing confirms the mold can withstand controlled concrete filling.
The mold is carefully oriented vertically to prepare for gravity-assisted casting. Once vertical, the mold is locked firmly to prevent movement during filling. Feed lines are aligned precisely to ensure uninterrupted concrete delivery. A sealed connection prevents pressure loss during continuous concrete filling. Internal sensors are activated to monitor flow, pressure, and vibration during casting. Concrete pumping begins slowly to stabilize pressure before full casting. Concrete is introduced gradually to eliminate trapped air at the mold base. Early-stage vibration compacts the base to form a dense, void-free foundation. Controlled pumping keeps the concrete column uniform as it rises. Sequential vibration equalizes density around the steel core. Vent control allows air to escape, preventing voids near the top section. Flow is slowed at the end to achieve exact final fill height. The fill is completed with precise leveling to define the pillar's final geometry. A final vibration cycle consolidates the surface and removes residual air. After filling, pressure is safely relieved to protect both equipment and structure. The mold is sealed completely to begin controlled concrete curing.
Early curing temperature is carefully stabilized to control concrete strength development.
Moisture control prevents cracking during the critical early curing stage.
Pressure balancing protects the mold as internal curing reactions progress.
Curing conditions are logged continuously to guarantee structural consistency.
Thermal scanning confirms even heat distribution during the curing process. Vibration isolation allows the concrete to gain strength without disturbance. Curing time is tracked precisely to ensure the pillar reaches design strength. Curing is now complete, and the pillar has reached its required structural strength. After curing, the mold is cooled gradually to protect the concrete structure.
Final inspections confirm the mold is safe to open without damaging the pillar.
With curing complete, the mold is carefully opened to begin demolding. Side clamps are released gradually to avoid stressing the cured concrete. Controlled separation confirms the pillar has released cleanly from the mold. The mold is fully retracted, revealing the finished concrete pillar. Surface inspection confirms the pillar meets visual and structural standards. Ultrasonic scanning verifies internal integrity beyond what the eye can see.
Laser alignment confirms the pillar's straightness for safe transoceanic installation.
Optical scanning detects micro cracks before the pillar moves to final handling.
Minor surface finishing ensures precise edges without altering structural strength.
Final cleaning prepares the pillar for protective treatment and handling.
A protective sealer shields the pillar from moisture and marine exposure. Absorption checks confirm the protective coating has bonded evenly. Controlled airflow cures the protective layer evenly without surface defects. Verified lift points ensure the pillar can be handled safely at full weight. Overhead cranes attach carefully to distribute the pillar's enormous weight. A controlled test lift confirms balance before full relocation begins.
The pillar is fully lifted clear, ready for controlled transport within the facility.
The completed pillar is transferred carefully to the finishing and holding area. The pillar is seated onto transport cradles designed to absorb its massive weight. Once the load is transferred, the crane is safely detached. Securing systems lock the pillar in place before any movement begins. The transport route is verified to ensure safe internal movement. The pillar begins its journey on an autonomous platform designed for extreme loads.
Internal transport systems move each pillar safely through the massive facility.
The pillar is positioned in a holding bay for final stabilization before storage preparation. Stabilizers lock the platform to eliminate movement during final inspections.
Final records are completed, marking the pillar ready for protective packaging.
Manufacturing is complete, and the pillar is cleared for the packaging phase. The packaging frame forms a protective structure without stressing the concrete surface.
Protective padding is prepared and tested to absorb transport shock.
Padding is installed carefully to protect the pillar during long-distance transport.
Midsection padding completes continuous impact protection along the pillar.
Upper padding locks in place to complete full-length impact protection.
The outer wrap secures padding and protect the pillar from moisture and abrasion.
Wrap tension and seals are verified to ensure long-distance transport durability. End caps protect critical edges during handling and long-range shipment. The top cap completes full impact protection for vertical handling and shipment. Final inspection confirms the pillar is fully protected and shipment ready. Transport cradles are reconfigured to handle extended transoceanic movement. The warehouse route is activated to guide safe movement into storage. The packaged pillar moves autonomously into the secured warehouse storage area. The pillar is aligned precisely within its designated warehouse storage slot. The pillar's weight is transferred to fixed supports for safe, long-term storage. The transport platform withdraws, leaving the pillar secured in storage. Environmental controls preserve structural integrity during extended warehouse storage. Stored pillars are continuously monitored to ensure long-term stability. The pillar is scheduled and assigned for transoceanic delivery.
The dispatch route is prepared to move the pillar safely out of storage.
The transport platform re-engages to begin the dispatch sequence. The pillar's weight is smoothly transferred back onto the transport platform. The pillar exits the warehouse, beginning its final journey toward delivery. The pillar arrives at the loading yard for final transfer to delivery transport. The delivery trailer aligns precisely to receive the packaged pillar. The pillar's weight is carefully transferred onto the heavy lift delivery trailer.
The load is locked down to withstand extreme transport conditions.
A final safety check confirms the load is fully cleared for departure. The journey begins as the pillar departs the factory for Transoceanic delivery.
The shipment reaches the port, ready for final loading onto a Transoceanic vessel.
The cable car pillar is secured aboard the vessel, completing its transoceanic journey.